Okay, I'm going to start working through these review problems for the Math 201 final exam. I think there are actually 81 problems, but hopefully a lot of them will go fairly quickly. So what I will do, just like the ones I did for the midterm exam, I will look at the problem and show it to you all, and then switch back and talk about it and work it out and hopefully get the correct answer. So let's go ahead and start. Once again, well, I've told you that before, I won't say that. All right, so here's the first problem. It says draw a graph to match the description given. So here's a multiple choice question. There are 4 possible answers, and it gives us some information. Information is about positive and negative derivatives, and also when the derivative is 0. Now there's 2 ways to do this kind of problem. You can always do a process of elimination and figure out which one's correct. Or you can take the information you're given and come up with the graph and see which one matches. Now for this first problem, let's try and create the graph, because that'll give me a chance to explain about positive and negative derivatives just to make sure it's clear. So let me write down the information I'm given, and then that can show you what I'm doing. So it says negative derivative. Of course, hopefully you realize that these are intervals. These are not points. So negative derivative from negative infinity to negative 8. And then also from negative 8 to 7. And then a positive derivative from 7 to infinity. And then derivative will equal 0, and this is just 1 point at x equals negative 8. So let me talk about this. Let's sort of try and sketch out a graph of what's going on here, and then we'll see if we can determine which answer is correct. When I think about derivatives, derivatives mean the same thing as slope. Some of you learned about graphing with a slope. So once again, a positive slope is when you go from left to right. If it goes up, that's a positive slope. A negative slope is when your graph or when your line goes down as you move from left to right. And then a slope of 0 is when your line is perfectly horizontal. So based upon the information they've given, let's try and make a little sketch here. So let me create a little XY graph. So let's say, looks like we start here. Let's put negative 8. And looks like we're going to go to 7. So obviously out here is negative infinity, and we out here is positive infinity. So it's saying there are 2 places on this graph where the derivative is negative, where the graph is going to be going down. So from negative infinity to negative 8, we have a negative derivative. So in this region here, you can sort of think that the graph is going down. And then also from negative 8 to 7, the graph is going down. Right? So here's negative infinity to negative 8. My graph is going to be decreasing, and from negative 8 to 7, it's decreasing. Now it's positive from 7 to infinity, so it's positive in here. And then the last piece of information is that at x equals -8, the derivative is 0. So I go here to -8 and just draw a very short sort of horizontal line. So here's a negative derivative. Here's a negative derivative. Here's a positive derivative. And here the derivative is 0. So if you try and match these up, basically, I think what you're going to have is, I'll just try and make a sketch where it's coming down, and then at -8, it flattens out just for one point, and then it comes down again. Once you get to 7, all of a sudden, the derivative is going to go from negative to positive, so it must. So in a sense, if I redraw it maybe a little bit neater, I think it's going to come, here's -8. It's going to come down, and right at -8, it's going to flatten out for just a minute, and then it's going to keep going down until you get to 7, and then it turns around and goes upward. Now our choices may not look exactly like that, but we should see one that has those trends. So if we go back, so obviously this one is not, because the first part of our graph, we're coming down. This one's going up. Okay, this one's going down. But you know, let me show you why this is not correct. It goes down at -8, it's flat, but then this one, the derivative goes positive. For us, it has to be a negative derivative, go flat, and then keep going negative. So that's not correct. Let's look at this one. So it starts out negative derivative. I assume -8 is in here someplace. It goes flat, and then it keeps going negative, which is good. And then it gets down to 7. I assume 7 is right here. Then it starts to go up. So this definitely looks like it's probably the correct one. So my guess is the answer is C. We can see D is obviously not correct. So I'm going to guess it's C, and that's correct. All right, number 2, same kind of problem. Maybe we can just talk about this one and look at the answers, and I'll have to work it out on paper. Draw a graph. H is decreasing over -infinity to infinity, but the derivative does not exist at x equals 4. So in other words, this is saying the whole graph is going down. The graph is decreasing, except something strange is happening at x equals 4. The graph is not defined, which means there's sort of a break in the graph at x equals 4. So just for fun, if we look through these examples to see if any of them fit, this first one, it's going down. Well, you can see here it's going up. So it's definitely not correct, because in our case, it has to be going down the whole time. If we look at B, it's going down. Then you notice here, a perfectly vertical line has an undefined slope, which means, I believe, that's what we're saying, the slope doesn't exist. And then it keeps going down. So this looks like a possibility. Let's just for fun look at the other ones. This one, it's going down. And then it looks like there's an asymptote. An asymptote is where there's no line. And then it picks up and it goes down. Now this one looks like it's also correct. So let's talk about B and C in a minute and see if we figure out which one's the correct answer. If I look at D, the derivative is positive, so it's definitely not correct. So this one's so tricky because what's going on here, if you look at the derivative of B, derivative is negative, negative. Derivative is what we say is undefined here, and derivative is negative. Now for C, here the derivative is negative, And then there's a break, and it starts again up here, and it's still negative. But the difference is in this one, the actual graph doesn't exist. And for B, the graph exists, but it's undefined. So since this one says derivative does not exist, to me, the wording is a little goofy because I think it could be either one, but my guess is I would choose C if I had to choose one. And it doesn't like it. So actually, if I chose B, that's correct. So once again, this is a matter of definitions, what they mean when the derivative does not exist. So in my opinion, it could be either one, but in this case, it actually was B. All right, number 3, find any critical values in a relative extrema. So that means basically, in my language, find the maxes and the mins for this function. So let me write the function down, and then we can start talking about how to find maxes and mins, at least the way I like to do it. So the function is, so this is number 3. F of x equals x squared plus 2x plus 6. All right, so here's what we have. When they say relative extreme, I usually think of find the maxes and mins. Now the whole key, these are also called critical points. The whole key is you take the first derivative of your function and you set it equal to 0 and you solve this. And the solution to this equation will be your critical points. And then once you determine what your critical points are, then we have to determine whether they're maxes or minimums, or occasionally we have one that's neither, but those are pretty rare. So here's what we do. Need to take the first derivative of this function. This one's pretty straightforward. Derivative of x squared is 2x. Derivative of 2x is just 2. Derivative of 6 is 0. So then you take this first derivative, you set it equal to 0, and you solve this equation. And when you solve this equation, you will have the critical point. So I'll subtract 2 from both sides. Divide both sides by 2. So here is my critical point. Now I have to determine, is that a maximum or a minimum? And here's the way I teach my students to do it. There are different ways to do it, and feel free to use a different way. You can always take the second derivative, but I'm just going to do it this way because on future problems, this is something we're going to use a lot. I like to go ahead and sort of create a graph, almost like a sine chart graph. You'll see what I mean in a minute. What I do is I go here, I think of this as my graph of my function, and I go to -1x, and I go here and I draw like a dashed vertical line. Because what I'm going to do is I'm going to break this up into 2 regions. Because what I know is the first derivative of region 1 is either going to be positive or negative, and it's not going to change. It's the same thing. You can think of, you can say from x equals -infinity to -1, the first derivative is either positive or negative. I don't know which. Region 2 says from -1 to positive infinity, the first derivative does not change. It's either positive or negative. So what I need to do is figure out what the first derivative is in region 1, what the sine of the first derivative is, and figure out what the sine of the first derivative is in region 2, and then I'll know what's going on at x equals 1. So what I typically do is I will choose a point in region 1, like I'll choose -2. And I go to my first derivative. You've got to check the first derivative. I'm going to plug in -2 for x in my first derivative and see what this function is. When I plug in -2, I get -4 plus 2, which ends up being a negative number. So I know in this region of the graph, my derivative, my first derivative is negative, and my function is going to decrease. All right, so once again, what I did is I choose a point in my first region, a value for x, -2. I plug it in the equation of the first derivative, and I calculate this. And in this case, I can write it here to make it very clear. When I plug in -2 to my first derivative, it equals -2. All I really care about is whether my answer is positive or negative. And since it's negative, I know region 1 is a negative region. The first derivative is negative. I do the same thing now for region 2. Matter of fact, for region 2, I'm going to choose 0 because x equals 0 is in region 2. When I plug in 0 into my first derivative, it equals 2, which is a positive, which means in region 2, my derivative is positive. So if this is sort of like my graph, it's pretty obvious. My graph is decreasing until I get to -1, and then it begins to increase. So what's going on right here at -1? Obviously, it's a minimum. Now, the interesting thing is, I don't know if they ask for the value of x. Sometimes they ask for the point. So I can say minimum at x equals -1, but sometimes they want the whole point. Now, if I want to get the whole point, x is -1, but what's the value of the function, or what's the value of y? I have to plug -1 back into my original equation. Don't plug it into the first derivative, plug it into the original equation. So in a sense, what I'm needing to do is f of -1, which is going to be -1 squared plus 2 times -1 plus 6. If I'm careful with this, this is 1 minus 2 plus 6. Looks like 5. So actually, my minimum is at -1,5. I'm not even sure what kind of answer they're looking for. So let's go back. And they're just simply looking for their critical value. So I didn't need to figure out the point. I believe I can just enter -1. All right. Oh, they asked some more questions. Select the correct choice below, and if necessary, fill in the answer with your choice. So here, it's just a critical value. Now they're asking us, is it a max or is it a min? We've already figured that out. All we have is a minimum and no maximum. So I think we're going to have this choice here, C. Now here they're asking for the point. So we do need the point after all. The relative minimum point is -1, 5, and there are no relative maximum points. Hopefully this is correct, and it is. Now, I think problem 4 says find any relative extrema of the function, so the maxes and mins. List each extrema along the x value which that occurs. Identify intervals in which the function is increasing or decreasing, and sketch the graph. So basically, they want you to find their critical points, find the maxes or mins, and eventually have an idea of what the sketch of the graph looks like. So really, I'm going to do what I did on the previous problem, and they're going to want to have all that information. So let me write down the function, and then we can work through it. So this is problem 4. And the function is f of x equals negative x cubed plus 3x squared. So we're going to find the maxes and the mins, and we're going to try and sketch a graph. And then after all that stuff, we'll have everything we need, I think, to give all the answers we're looking for. So once again, how do we find their first step is find their critical points, which is usually either maxes or mins. Critical points, you take the first derivative of the function. So in this case, negative 3x squared plus 6x. Then you go ahead and you set that equal to 0. And we're going to solve this equation, and this will be our critical points. Here, I'm going to go and factor. So let's factor out a 3x. So I'd have negative x plus 2. And now to solve this, if I look at the 3x here, what value of x would cause this whole equation to be 0? 0. What value of x would I put inside the parenthesis? 2. So it looks like there are 2 critical points, 0 and 2. I don't know whether those points are maximums or mins, or one's a max and one's a min. The way I'm going to choose to do it, and this is why I do this little graphing sort of sign chart, is because once I do this, I'll also have a pretty good idea of what the graph looks like, which I'm going to need. So I go mark my points. 0, and I put a dashed line at x equals 0. And then 2 is right here. So therefore, this breaks up my graph into 3 regions. So x starts at negative infinity and x goes to infinity. Hopefully you can see the first region is like negative infinity to 0. Second region is 0 to 2, and the third region is 2 to infinity. I need to find the sine of the first derivative in each of these 3 regions. So once again, here is I'm going to rewrite my first derivative in a little nicer form, make it easier for me. Let me write it here. First derivative is going to be 3x times 2 minus x. So I'm going to pick a value of x in each region. So in region 1, I'll choose minus 1 right here. So I'm going to plug in minus 1 into my first derivative. And really all I care about is the signs. I don't care about the numbers. So I'm going to just 3 times negative 1 is a negative. 2 minus a negative 1, that's like 2 plus 1, so this is positive. I have a negative times a positive. I know region 1's a negative region, so my graph is going to be decreasing in region 1. If I go to region 2, I have to pick a value of x between 0 and 2. I'll pick 1. So once again, I look at the first derivative when x is 1. This 3x is positive. 2 minus x, 2 minus 1 is 1. The parentheses are positive. Region 2 is a positive region, so I know it's going to go up. So I know now when x is 0, it looks like I have a minimum. For region 3, I'll pick a value of 3. If you hear in the background, I think my wife is cooking something, hopefully not too distracting. So first derivative for 3, I plug in 3. 3 times 3 is a positive. 2 minus 3 is a negative. Therefore, region 3 is negative. And I can see it drops down like this. So it looks like I'm going to have a maximum when x is 2. So now I think I really have all the information I need to answer the questions. So let me go back and see what the actual questions are, or at least most of the information. Now, the one thing they probably want, well, let's just summarize here. So I have a minimum at x equals 0, and that point is going to be 0. Once again, I go back to the original equation, plug in 0 for x, and it's going to be 0, 0. I have a maximum when x is 2. If I go plug in 2 into this point, I'm going to have negative 8 plus 12, which is 4. So here's my min and my max in terms of the point. So I hope I've got everything I'm going to need to answer these questions. So first question, describe any relative extrema. So now I'm already asking for the mins and the maxes. We've got one of each. So I'm going to choose this middle one. The relative minimum is, we said it's 0, 0. And the relative maximum is 2, 4. Hope I didn't make any mistakes. That's good. Now the next question. Identify any intervals at which the function is increasing or decreasing. So if we look, let's go back to my little graph. Hopefully you can see that this is sort of my graph, decreasing, the minimum, increasing, the maximum, decreasing. So you can see region 1 is like a decreasing, region 2 is like increasing, and region 3 is decreasing. So 2 regions where the graph is decreasing, the function is decreasing, and 1 region where the function is increasing. So let's go back and try to fill in the answers. So I have decreasing and increasing. So increasing, and these are intervals. Increasing went from 0 to 2. And then decreasing, I've got 2 intervals. First one is negative infinity to 0. So I have to go to the bottom to click on my little infinity to 0. And then I think I put a comma here, and then another interval of 2 to positive infinity. All right, that's good. And then the graph, now that graph won't look quite like mine, but the shape should be the same. So it starts out decreasing until 0, and then increasing to 2, and then decreasing again. So A and B are the only ones that fit, and I can sort of see looking here, this maximum looks like it's 0, but my maximum has to be at 2. So I'm going to expand this A and see if it's correct. So decreasing, minimum at 0, increasing, maximum at 2, decreasing. Looks like A is the correct graph. All right. I'm going to stop now and start the next video in just a minute.